This is lesson 4.3. It's a problem-solving investigation using the strategy make an organized list. Nikki says, I am ordering a pizza. The crust choices are thin or hand-tossed. The meat choices are pepperoni or sausage. The vegetable choices are olives, mushrooms, or banana peppers. What we need to do is to make an organized list to find how many different types of pizza Nikki can order. You know the crust, you know the meat, you know the vegetable options. You need to find all possible pizza combinations. To make an organized list, we're going to use P for pepperoni, or T for thin, H for hand-tossed, P for pepperoni, S for sausage, O for olives, M for mushrooms, and B for banana peppers. So we're choosing the crust. We have 6 possible combinations with thin crust: pepperoni olives, pepperoni mushrooms, pepperoni bell peppers, thin crust sausage olives, sausage mushrooms, sausage banana peppers. With the hand-tossed crust, we have pepperoni olives, pepperoni mushrooms, pepperoni bell peppers, or banana peppers, sausage olives, sausage mushrooms, sausage banana peppers. If you count the combinations, you come up with a number of 12. The last step is to draw a tree diagram to check the result. We'll do that in just a minute. Why does making an organized list, why is that a useful strategy in solving the problem? By making an organized list, you can show all the possible pizza combinations. You don't just know how many there are, you can actually show them. And by working in an organized way, like we did here where we did all the thin crust, then all the hand-tossed, and you can see the same thing here written in a little different way. We worked in an orderly fashion so that we didn't have any duplication, and we didn't also exclude any. Now we're going to make a diagram, a tree diagram, to check those choices, see if we did them right. I much prefer the organized list. The tree diagram can get really busy. This one isn't too bad because it's fairly small. We're going to start with thin. We're going to do pepperoni. We're going to do sausage. And for each of these, it's mushrooms, olives, banana peppers, mushrooms, olives, banana peppers. Now, if we do this correctly, we should end up with 12 choices. So, hand-tossed, pepperoni, sausage, mushrooms, olives, banana peppers, sausage, mushrooms, olives, banana peppers. If we go here and count them, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which agrees with our organized list. So we have apparently used the strategy correctly. Write a problem that can be solved by making an organized list and explain how to solve the problem using the strategy. The problem I came up with was, how many different ways can a woodwind trio be made if the first position needs to be either a bass clarinet or a bassoon? The other 2 positions should be filled by a clarinet, oboe, or flute. So again, in my organized list, I made all the combinations first with the bass, clarinet. So I have bass, clarinet, and the clarinet. I have the bass, clarinet, and the oboe. I have the bass, clarinet, and the flute. Then I did the bassoon, and again it's bassoon, clarinet, bassoon, oboe, bassoon, flute, and when I count them, I come up with 6 possible combinations. Problem number 3. Charmaine went to the store, bought a yellow shirt, a blue shirt, and a red shirt. She also bought a pair of jeans and a pair of khaki dress pants. How many different outfits can be made using one shirt and one pair of pants? So we're going to do this. We're going to use yellow for the yellow shirt, B for the blue shirt, R for the red shirt. We're going to use J for jeans, K for khaki. So what we're going to do first is we're going to make the combinations with the yellow shirt, which means yellow jeans, yellow khaki. Then we're going to do blue and jeans, blue and khaki. Then we're going to do red and jeans, red and khaki. And I hope you can see the organization there. We come up with 6 combinations. Number 4, a little more involved here, a lot more outcomes. The following 4 numbers are used for employee identification numbers on a small company, 0, 1, 2, and 3. How many different employee identification numbers can be made using each digit? This list is a little more involved, but again follows the same organization. I made all the combinations I could start with a 0. I did 0, 1, and the 2 combinations there, and then 0, 2, and then 0, 4. Then I made all the combinations I could that started with 1, and I did 1, 0, 1, 2, 1, 4, and then 2, 2, 0, 2, 1, 2, 4, 4, 4, 0, 4, 1, 4, 2, and I came up with, as you can see, 24 combinations. Problem number 5. Joshua, Diego, and Audrey stand side by side for a photograph. How many different ways can the 3 friends stand next to each other? So J for Joshua, D for Diego, and A for Audrey. So we're going to do the ones where Joshua is first. We have 1 there, Joshua, Diego, Audrey, Joshua, Audrey, Diego. And then we're going to put Diego first. And so we got Diego, Audrey, Joshua, Diego, Joshua, Audrey, because they are different. And then finally the ones where Audrey is first. And in that case it's Joshua, Diego, and then Audrey, Diego, Joshua. And what we come up with is 6 combinations. Now our last problem we're going to do is the cell phone problem. How many phone numbers are possible for one area code if the first 3 numbers are 268? So we don't have to worry about that. All of these numbers we made over here are going to start with 268 in that order, and the last 4 numbers are 0, 9, 7, 1 in any order. So again, almost the same as problem number 4. I made all the combinations I could to start with 0. I did 0, 1, 0, 7, 0, 9. Then I did all the 1s, 0, 1, 0, 7, 0, 9. Then all the 7s, 7, 0, 7, 1, 7, 9. And then all the 9s, 9, 0, 9, 1, 9, 7. And then I just flip-flopped the last 2 numbers. And again, I came up with 24 possible combinations. This is a quick overview of the strategy, use an organized list.